What's up guys, welcome back to the channel. Today I'm going to be showing you how I build this super flat, super cheap welding table behind me. We're going to be using a T-slotted CNC machine table, and then I'm going to build a really beefy base, and I'll show you some of the materials we're going to be using so we can make sure this thing is really stout. Let me show you what we got. All right, here's a closer look at some of the casters we're going to be using. These are basically the biggest, baddest casters I could find for the money. I paid $79 each for these, and I got a coupon when I bought them on Northern Tool. They're good for about 2,600 pounds each. I don't know what the math is off the top of my head, but we're doing about 6 of these. So it's probably like 15,000 pounds roughly. And then what we're gonna be doing for adjustability is I have these massive nuts, and then I have some thread here in the front. I ended up getting that thread free from McMaster-Carr just because it was sent wrong. So that is 1 3/4 inch by 5. We're going to be using that along with these big nuts that I picked up online on McMaster-Carr to adjust the wheel heights so we can get everything set up. And we're going to be doing 6 wheels so that everything is nice and stable. Currently I'm using just a beater welding table right now. It's not flat, and that's been a major problem, and I just have 4 wheels. They're off of a Lista cabinet, so they are pretty heavy duty, but they just don't cut it. So moving over to 6 wheels, like some of the really nice welding tables have, and then moving up to basically the biggest wheels I could find will really help mitigate the issue of making this table hard to roll, and it should allow us to really be able to load this table up. Now for the legs, we're going to be using some of this 5-inch quarter wall tubing, and I got this as part of a deal when I bought a bunch of metal, so as of right now it's basically free. I have it on the shelf. And then over to the left, you probably can just see the edge of it. I picked up some 3-inch, 3/16 wall square tubing as well. That stuff cost me a pretty penny, about 500 bucks. It's pretty much the only thing aside from the casters and the nuts that I had to buy for this. So we're gonna be using that for cross braces. So let's go ahead and start by making the bottom plates that these nuts sit on and go from there. All right guys, we're set up at the saw. We're gonna be using this 1/2-inch material. It's 5.5 inches tall, and we're gonna be cutting 5.5-inch squares. This is gonna leave us a 1/4 inch around the perimeter for welding when we bring our 5x5 square tube up to it. Let's go ahead and get 6 of these cut. That's for vibration. Once the blade gets fully into the material, the vibration will cut down. And there she is. I just kind of love the beautiful cut that this saw gives. 250-pound piece of steel coming through. That's why you need a jib crane, which we're working on. 8-inch by 8-inch by 5 foot long. We don't need the whole length. We're gonna cut these up into 8-inch squares, 3/4 inch thick. Definitely overkill, but why the heck not? All right, we got this overkill 3/4 inch plate up here. We're gonna chop it up. It is a little bit oversized, but our caster base plates are 7 by 7. So this will give us about a 1/2 inch around the perimeter of the casters, and we can make 6 of these for the swivel bases. Let's get these cut. This is what I love about my HYDMECH. Just eating 8-inch plate for breakfast. We got a 300-pound piece about in the saw, and I'm cutting it up into 8-inch squares. Has no problem ripping right through this chunker. 30 years old and still going strong. All right, we're over here at the radial arm drill, setting up to drill some center holes for a larger 1.5-inch drill bit. We got the HYDMECH going over there to the right, knocking out our last plate, and we're gonna go ahead and get these drilled. Looks like we're set to 252 RPMs with a feed rate of 6 thousandths per rev. Let's get drilling. We're drilling 3/4 inch thick plate. Let's get to work. The RPM is correct. I know I got some people that are going to be freaking out about these stringy chips. There's a chart on the radial drill indicating the speeds, and we're on the conservative side. And we're through. All right, we're going to be punching an 1.5-inch hole here. We have a 3/4 inch pilot. We're going 60 RPM and a 6,000 speed rate. Let's get going. All right, we're getting ready to drill a 1.5-inch hole and 3/4 inch plate. We're going at 144 RPMs and 6 thousandths per rev. Let's get drilling. Lots of lube. This thing will punch a hole right through this. Man, ain't nothing like a good radial arm drill. A little rough on the start, and once it finds a home, it's good to go. Over here at the American, we're going to get these plates bored out. That way it's a nice close fit on our threaded rod. RPM is 1,000. Feed rate is 16,000 per rev. Making a nice healthy chip there. Probably a little unnecessarily heavy, but whatever. And I'm going to cut on the back stroke. Kind of clean it up. Insert's looking good. All right, success. We're gonna go ahead and QC this. See where we landed. 1.727. All right, we got you chucked up in the blue lathe, just so I can show you why I wanted to get this board out so we can press fit these on. This allows me to go ahead and get a really nice fit to minimize the run out on the plate. And then when we weld the back, we'll do a plug weld, and hopefully this will keep us relatively straight. We got these 8x8 plates all cut up, drilled out, and bored on the lathe. And then these are the 1/2-inch plates we cut for the bottom of the 5.5 by 5.5s. This is the concept of what we're doing over here. We got a threaded rod that I want to get pushed into this hole so it's a nice tight fit so we can make sure this is square. And then we'll come around back and weld around the back and do a plug weld. I'll make sure this is pushed down a little bit more so we can get some more meat on that weld. And then I'm going to have 2 nuts right here. One nut is going to screw on to this shaft, and it'll be a jam nut so we can lock the position for the height. And then the other nut is going to be welded onto the bottom of this plate that goes on the bottom of the 5x5. That way it'll provide threads for the bottom of the leg. And then this plate is going to be for this 7x7 caster. And we're going to go over to the mill and drill and tap these holes next. We're over here at the Bridgeport popping some holes in these plates. Instead of doing 4 holes at once, what I'm going to do is do a little assembly line action where I actually take this piece out and put all 6 pieces in the same location, and then move over a hole and do the same thing. That'll speed up the operation and keep us moving along. Back over at the radial arm drill press, we need to tap 4 holes in each of these plates. We got 6 plates, so that's 24 holes. We're going to be doing this over here. I've got one of those Colchester tap holders so we can hold the tap firmly, and this radial drill has the ability to tap down in one direction, and by quickly tapping the spindle it will reverse up. So let's go ahead and get these holes tapped. There we go, one down, one to go. I leave the head floating so that it can find the hole and just let it go to town. Creates a perfect hole, nice and efficiently. Just like that, we were able to get this plate tapped, maybe in about 2 minutes total, all 4 holes, not too bad. Before we go ahead and get these welded up, I want to clean up the edges. The tool we're going to be using for this is one of these pneumatic bevelers. This is just a cheap one I got on Amazon, but it seems to be working pretty well. We'll go ahead and do the perimeter on both sides and then the inner. Make sure you wear hearing protection when doing this because these guys are loud. Cleaned up real nice. Kind of take a look there. Not too bad. I probably was going the wrong direction. So this is spinning in this direction. So it's going this way. I don't want to go that way. I want to go the opposite of it. Just like a router, I would assume. Not too bad. Not too bad at all. All right, we're gonna punch a hole in 6 of these plates. This is just to clear the web. It's a little big, but it'll work fine. 252 RPMs, 11 thousandths feed rate. No coolant for the video's sake. Nothing crazy, this is just a little hole. The accuracy of this is not that important. Let me just be clear about that. Trying to get it as close as I can, but it doesn't need to be. Yes, I know if we run coolant, the bit will last longer. I'm aware of that. It'll be fine. This is what's really nice about a radial drill, just being able to efficiently drill some big holes. Ladies and gentlemen, this is where the fun begins. We got a 2-inch Morse taper 4-bit. We're gonna be running at 80 RPMs with the slowest feed rate, which is 6 thousandths per rev. This is the biggest bit I've run on here. We're gonna run it dry. It will be fine. I'm doing it for the video. Yeah, let's have fun. Take a big bite. We're starting out slow. Slow is good with a 2-inch drill bit, especially since I haven't drilled anything this big before in one shot. Getting a decent amount of vibration. But I think once we establish a path, we should be good. There we go, it cooled down. All right, that's looking real good. Make sure our table and vise are tight, obviously. Just want to make sure it fully cleans up. Not bad at all. It's a pretty quick way to put a 2-inch hole in something. We got our clearance hole cut for the screw, but I want to have a way so I can center this so when I weld it, it's not offset. So we're just going to kind of tree pan a little bit over. That way the nut has somewhere to sit. Touch off. I'm going to go down 100 thousandths. Roughly, doesn't. And then we're going to come over to about 2.90. There we go. What's up, guys? We're back at the bench. As you notice, we're on a card table. It's actually been a couple months since I've been working on this project, and we're back at it. A few things have changed. The old bench that I used, I demolished, and I actually reassembled parts of it over there to make a better section for a tooling. And I installed a jib crane over here and a jib crane over there, and I've been pretty busy. So we're back at it. We got this because we don't have another bench, but this will get me motivated to get this welding table done so we can have a place to put things. All right, so you saw me go ahead and make these brackets. These brackets over here are for the caster plates. They're gonna come on here, and we have some 1/2-inch bolts going through there to hold these guys on. We have over here in this corner, this is the method I'm gonna be using to weld the rods onto the plates. So you can't really tell here because the rod is in here, but we have this threaded rod that you seen me work with earlier. So what I want to do is I want to weld this stud or stem to this plate like this, all right? And then this will be inverse, welded on the bottom so that it can thread up and this base can be adjusted. And then we have some extra nuts to go ahead and lock this so that it doesn't move. So a couple things that I wanted to do to keep everything in line. The first thing is when I weld this, I didn't want it to bend, so that way when I adjusted the casters, it wasn't wobbling. So what we did is we bored these out on the lathe, so this could be a nice fit. Ideally, a little bit of a press fit to keep it square. And then over here is the technique I'm going to use to weld this. I've never done this or seen this, but it made sense to me. When I weld it, I don't want it to move. So I'm going to do a plug weld on the back, which will have a little bit less pressure. But I'm going to use the chuck to kind of hold this square. And this is a spare chuck, so don't freak out about precision and all that stuff. And then I'm going to take this and I'm going to drop it on the back. And I'm actually going to recess it. So I'm going to drop it down. The chuck will hold it square. And then this face back here is obviously square. And then this will sit nice on that. It'll be up a little bit more. And then I can plug weld the back while I clamp this down to the chuck. And I'm hoping that that will keep that rod square. And we'll see. And then I will come over on the front once that shaft is in here, and I will do a weld around the perimeter. So that's that section. Over here, I went over to the radial drill, which you saw, and I punched a 2-inch hole in here so that we could have clearance for the stud or the rod coming through. And then I wanted to make sure when I welded these guys that I wasn't going to be able to like weld them offset and then it would contact. So I went over on the lathe and just turned this about 100 thousandths deep so that this can kind of find its home, sit in there nicely, and then when I go and weld around the perimeter, I know that this is centered up. It's going a little bit extra, not really required, but I just want to make sure everything is as straight as possible. We're going to have a lot of weight on this table, and I want to make sure the wheels rotate smoothly and they rotate straight, and everything is nice and overbuilt. The table itself is probably, I don't know, 3,000 to 4,000 pounds just for the top. All this extra weight's probably going to be another maybe 1,000, maybe 600, and then whatever I put on top of it. So I really wanted to overbuild this. So let's go ahead and start to assemble this stuff and go from there. All right, we got this clamped up. I'm going to go ahead and full commitment weld this on the back, and then we'll put it in the lathe and see how true it is. Hopefully we can get this to stay pretty true. We'll see. I'm just gonna tack it to start, and then let's weld it up. All right, not trying to go for prettiness here, we're going for penetration. All right, here's the moment of truth. I haven't looked at it yet. Honestly, I'll be happy with less than 30 thousandths of wobble, but we'll see how we did. Step over here where I can see it. I am very happy with that. 30 thousandths is what I'd be happy with. If it's less, of course, I'm gonna be really happy. And we got some bolt holes here. And this is hot rolled, so it's not perfect. But let's just take a look. Looks like 10. That is really good for doing this. All right, let's weld the front and see how we do. I'm very, very happy with that. That was a great technique. I've done a couple different weldments like this where you got a rod welded to a plate, and it's really hard to get them to where they're not wobbling around. So within 10 thousandths, I'm very, very happy with that. Let's weld the front here and see how much it affects that. But that's more than good enough. That's perfect. All right, we went ahead and put a weld bead on the front over here. We're just taking a look at it and seeing how much it threw it off there. And if I'm not mistaken, we need to really zero it too much. It's either slightly better, that's about the same. Okay, perfect, that's great. Fully welded, and it's within 10 thousandths. I'm very happy with that. We're over here on the floor making good use of the welding table. I got these nuts positioned on the plates here, and I got them clamped down so they don't move. I'm gonna go ahead and tack it in 4 or 5 sides and then finish welding it out. It doesn't really need to be welded overly because I'm gonna have the nut facing down. That way gravity is working against the plate and we're not relying on the weld. So let's go ahead and get these 6 plates welded out. Here we go, that should be more than fine. Here's some of the fun stuff you don't think about when you're building. How to get to the steel you got. I have a huge piece of steel back here that I'm going to be using for the table, and it's buried. I did get it up here, probably with the help of someone else, but it's in the back. And I don't know what it weighs, maybe 400 pounds. I'm not going to be lifting anything, but we're going to be scooting stuff to try to get to that piece of steel. It's about 16 feet long. Looks like it's maybe 8 inches by 2 inches, and it's quarter wall maybe. So yeah, so we're gonna try to get that piece of steel out of there. You know it's heavy when you can't even scoot it. Got to the piece that we're looking for. It's a long one. Oh, look at that. Look at that. Science, right? Levers, hurry. In the squatting position. Now I know most of you guys are asking yourself, why did I put the steel up here? It's a great question. I don't access this that often. and steel takes up a lot of floor space. I got 3 racks up here actually, and the one rack is real easy to get to, and the 2 racks on the ends are less easy, this one being the hardest and the bottom being the worst. I've been here 2 years. I've never touched anything on the bottom shelf. I'd rather have it difficult to get to a piece for an hour, especially something that I don't access that often, than put this on the floor, take up shop space, and be blocking me from machinery. So that's why. We're looking good. It's just extremely long. All right, we're gonna get the forklift over here and finish this off. All right, sling time. Making sure not to walk underneath it. I'll measure for the center line, 16 feet exactly. Get the jib over here. Get it to it at the center point. Oh, balance is good. We're over here at the HYDMECH S20. Gonna cut this box tubing here for the legs. This is gonna be what I'm gonna call a stub frame. Most of the time a frame on a bench is, you know, the height minus whatever the thickness is, but because we have such a thick top and some huge casters and some huge adjusting plates, this is all that we need left for our legs. So super stubby, super beefy, and this is quarter wall, and we're gonna be making 14-inch cuts, and we need 6 of them. Let's get started. Just saw choose for this like it's nothing. One, 2, 3, 4, 5, 6. Now it's time to cut the cross beams. This is some quarter wall, 8 by 3. We're gonna be making 38-inch cuts, and we're gonna need 4 of them at 38, and then 3 of them for the middle braces, I think at like 22. Let's get these cut. All right, guys, we got this all tacked together. It's looking pretty good. The next step is gonna be a little bit interesting. Typically what you would do in something like this is go ahead and get this all clamped down and fully welded out. The problem that we have is due to the height of these rails, I don't have any clamps that will work with this table yet and clamp this down. I could be wrong, but I feel like if I just go hog wild and weld this out, this is gonna kind of bend and warp, which is not ideal. So what we're gonna do, a little bit of an experiment here. I'm actually gonna put some cross beams in here, which will help anyway, because I'm gonna do a shelf. And then I'm gonna put some weight on top of here. I got a little bit of a weird idea, but it's the best I got. I'm gonna come around and I'm just gonna overly tack everything. So try to prevent everything from moving, but not put too much heat in it. And then I'm actually gonna take my 4-wheeler and sit it on top. And I'm gonna do that because I don't really have too much heavy stuff laying around here. I do have that arbor press over there I thought of sitting on here. But I wanna be able to put at least 500 pounds of weight, downward force, more ideally, but anything that I have as heavy is not mobile. So I can drive that over here, use the jib crane to lift it on and set it down. And hopefully that weight, it's about 750 pounds, will just kind of keep everything from curling up. If it moves sideways, it's not as big of a deal, but I really would like it to be flat. And right now it is flat on the table. So we'll go ahead and get this squared away and get to doing that. All right, not bad. We got it on there. Hopefully that provides enough downward support to kind of keep our frame from warping up. This thing's about 750. So hopefully that's enough to keep everything pressed down while we go ahead and get this welded out. All right, guys, we got this frame welded out and I'm very happy with how it turned out. When I had it upside down, there was absolutely no rock. So I'm not sure if that was the strategy of doing the spot welds or the weight from the four-wheeler or a little bit of both, but I'm very happy with it. There may be about 5 thousandths movement on this frame, maybe, which is plenty good because it is gonna flex slightly with the weight of the table and the difference in the floor. So I'm very happy with how that turned out. It's very beefy, very overkill. I went ahead and flipped it upside down and then welded the pads on the bottom. So yeah, we're looking really good. We put in these cross bracings here. That's just gonna allow for some plywood that I'm gonna put on so that I have a shelf here and just give a little bit extra support. It's a little bit overkill, but hey, that's the theme of this bench. So overall, I'm really happy with how it turned out. All we really gotta do is get the casters bolted up, get this thing painted, and then I may go around and install some like pegs or rods for some stuff to hang on to. So let's get that all finished up and then we'll meet back here when it's done. All right, let's get this clamp rack installed. It may look a little low, but I'm doing it this way just because I have some really large C-clamps, like heavy duty industrial ones that I want to be able to get on here. And I got to put this bar a little lower for that reason. Just get it tacked up. There we go. Should be rigid enough, don't you think? Definitely. And here's a sample. I need 8 inches of clearance. Now obviously it's gonna hit the table, but I need to be able to get it in from the top. You know, the table will be this way. So I needed 8.5 inches of clearance so I could go over the top and drop it down. So we'll do the same thing on the other side and it should be all good. All right, guys, we got the caster set up here. Just wanted to give you a shot of what we're working with. As you can see, the plates are real beefy, but they match the largeness of the wheels, as do the shafts. We got the nuts on all these. That'll just provide as a jam nut for when we level each leg individually. And other than that, we're pretty much ready to go. We're gonna get the frame lifted up with a hoist and flipped over, and then we'll get these caster plates screwed on. All right, let's get these bad boys screwed on. These casters are pretty heavy. All right, let's see how much this bad boy weighs. I'm guessing 500. Wow, I'm proud of that. 750 pounds. Some good mass right there. Unfortunately, I don't know how much this weighs. I know it's too much for my crane. I think my forklift lifted it, but it struggled. So we're gonna lift it over there with the lift. All right, so we gotta move this all the way over to the automotive lift. I got it on machine skates, very low quality skates. And we're just gonna take a pry bar and we're gonna scoot it. I've swept the floor and I'll take a check every minute. Yeah, they're good so far. This is a good way to move machinery. You can get it on wheels and just take a pry bar, flip it upside down, and scoot it. We're just gonna get it as far as we can go. We're so close. Once we're in position, I'm gonna change the skates and rotate them so we can slide it sideways. Luckily, hopefully this will be the last time I gotta do this. I gotta turn my back to the camera over here. I apologize. Gotta love a good toe jack. Same technique. Now let's see if we get lucky enough that my lift fits underneath this buddy. Oh, definitely not. But I think what we're gonna do, we're gonna get it close and we're gonna use a toe jack to get it up higher. Looks like my skate fell off the back. It's kind of hurting us. Touchdown. All right guys, today is a very exciting day. We're getting ready to open the Fireball tool vise. I've had it for over 6 months. It's just been sitting because I've been too busy and I didn't have a place to put it. So we're gonna get this thing opened up and get it lifted out and get it set up on the bench. And we resurrect the beast. I'm gonna get the hole locations marked with a center punch here. I actually decided to make a drill bushing so I can get a little bit of a more accurate hole. I'm just gonna use a drill bit to get it started. We've got the table over here at the radial arm drill. We're gonna go ahead and get all 4 of these holes drilled for 21 32nd, and then come in here with a 3/4 10 tap and power tap it with the radial arm drill. Let's get started. We're drilling a little over 2.5 inches deep. All right, it's time to do some tapping on the radial arm drill press. We're using a 3/4 10 tap. I know a spiral tap would be better, but let's see if this thing will give us what we want. Look at that, nice and easy, a perfect hole. All right, touchdown. Hopefully all these holes will line up nicely. Using some beefy washers here. And some 2.5 inch long bolts. We wanted to make sure this thing wasn't going anywhere. There we go. And I think we're gonna be perfect. All right guys, I am super happy. We finally got this vise installed. I've had it sitting in the box for at least 6 months, and we got a huge piece of hydraulic tube up here just to kind of show what this vise can do. It can actually go, I don't even know, 4 more inches, 8 more inches. It goes really wide. This vise is overkill, this cable is overkill, and this pipe is overkill. It all works really nice together. I'm not going to do a full review here of this vise. We're just mounting it and showing that it's on the table. But overall, I am really happy with the vise. It's very heavy duty. The flange moves nice and easy. The handle doesn't have any real backlash. It does have some. The jaw does move back and forth. I don't know, maybe 10 thousandths. Very, very low. Very acceptable. And overall, just really smooth and stout. I'm really happy with this. This was a purchase that I had been waiting for about 1.5 years. And to finally have this mounted up is awesome. I've been waiting to use this thing forever, and now it's gonna get used. So it'll be nice having this right here by the lathe, by all 3 lathes, and just in the center on the workbench. And the nice thing about this table is it is 9 feet long. So even though I am losing some space here, I'll still be able to put about an 8-foot piece on this table for weldment. And if I need to, I got the jib crane. I can just take this vise off, move it out of the way, and be good to go. So yeah, vise is installed. All we got left to do is get this bench painted and get everything hung on here, and we're ready to go. Well, it's been about 3 months later, and I waited to do the last part of the video here just so I could get you an idea of how this table works in the real world, and I absolutely love it. The other thing I was waiting on is getting these clamps manufactured, or at least the adapter plates at the bottom, so I could use them on the table and let you know how that works out, and they work out absolutely great. I ended up machining a little spacer on the bottom, and I'm using these 3/4 inch clamps from Fireball so I can slide them along the table, and because of the reach and the way the spacing is, I can reach pretty much anything. We got the vise mounted, we got the base painted, and I got my squares hanging off the bottom. Overall, I'm really happy with how this turns out. I've had a ton of pieces of equipment up on here while I'm restoring stuff and fixing stuff. It's nice and heavy duty, so I don't have to worry about stuff weighing the table down, or the table breaking or bending or bowing, which is excellent. This is a really nice flat surface for what I'm doing. Ultimately, it'll be perfect. I know a lot of you guys are wondering, how flat is this? If you're doing aerospace work, I'm sure you could get it even flatter table out there, but for what I'm doing, this is perfect. I don't have a straight edge this long, but using a 6-inch camelback straight edge, it's pretty close. I would say it's within 10 or 20 thousandths over the whole distance, and that's plenty good for what I'm doing. And I would imagine, being cast and being a horizontal boring mill table, it's probably started out life with around 1 thousandths or less accuracy over the whole thing. Now it is used, so even if it lost a couple thousandths, it's possible it could be even more accurate than that. But either way, it's plenty accurate for what I want. Overall, I hope you guys enjoyed the video. I hope this is a cool idea that you can take away on how to get a really flat, sturdy table relatively cheap. And we'll see you in the next one.